Welcome to our presentation on a textual analysis of economic speeches on agriculture. The overall task of our project is to perform topic modeling on about 4,000 speeches and articles from the Agricultural and Applied Economics Association between 1919 and 2022. Our major motivation for this project is to assess the shifts of discussion of topics in the literature, since these shifts have important policy implications. For example, we would like to see if discussion of sustainability and climate change related topics has increased in recent decades. We use natural language processing methods like latent Dirichlet allocation and BERT topic to do topic modeling. And lastly, we did some demographic analysis to further investigate the relationships between specific topics and predicted author race, as well as predicted author gender over time.
The first step of our project is data preprocessing. To do this, we downloaded all of our data in PDF format off of the Zotero online library, which was collected by other researchers. Once this is completed, we use an optical character recognition program called Tesseract to convert the PDFs into text files. Next, we filter stop words and lemmatize the text, which converts all the words into their root forms. We then identify common and rare words throughout the text and remove them. Finally, we write the filtered text along with some metadata to a CSV for use in the models. The first model that we use is latent Dirichlet allocation, or LDA, which is a common machine learning method that identifies common topics, which are just weighted collections of words that frequently appear together. We use the GenSim library for additional pre-processing and model generation.
Here is an example of two topics produced by LDA. One of our faculty leads, Dr. Wilson, named all 25 of our LDA topics. The topic on the top was labeled environmental resource management, and the topic on the bottom was labeled international trade. Within LDA, we can do something called coherence modeling to find the optimal number of topics. Coherence is a measure of the overall interpretability of a topic. We found that 25 topics produces the maximum coherence value, so that's what we selected for our model.
Next, we analyze trends in the frequency of the topics generated by our LDA model over time, specifically looking for topics that either increased or decreased in prevalence over time. From the left graph, we observed an increase in discussion topics such as econometrics, environmental and resource management, and water, but the increase in environmental topics is generally less than the other increasing topics. From the right graph, we noticed a decrease in the mention of international trade.
Further analysis also allowed us to longitudinally investigate the demographics of the authors. So firstly, we used Python's gender guesser package to go through every author's first name, predict the gender with about a 95% confidence interval, and model that over time. And as you can see, we've learned that the proportion of authors who were generally female increased, although there was no increase in the proportion of primary authors who were female. So this increase is all due to secondary female authors. We also used Bayesian improved surname geocoding, or BizG, to predict the race of each author based on last name. After modeling that over time as well, we see a consistently white-dominated field, although AAPI authors are beginning to displace a little bit of that dominance, while no other race is gaining any significant ground. Next, in addition to using LDA modeling, we also use BERT topic, which is another topic modeling counterpart to LDA. In addition to being a little bit more tailored to the digital humanities, BERT topic is also designed to work optimally with larger corpuses. Most importantly, BERT topic is a little bit more nuanced into the analysis of which topics are pieces of other topics. That allows us to create a topic hierarchy, or a big map of all the topics that allows us to understand which topics are discussed together and which are slightly out of the picture, slightly isolated. In the topic hierarchy chart, the difference in color indicates a larger difference in topics. We selected this proportion of topics in order to show multiple different sections of the chart. So this is just a piece of the broader map that we've made. As far as future studies, we hope to do more in-depth analysis of topics, specifically looking at topics over time by gender to see if certain genders are writing more about certain topics. And further, we want to do a more in-depth analysis of the comparison between LDA and BERT topic, as well as the nature of the different analyses they're producing. Thank you so much for listening to the presentation. Here are our references, and yeah, thank you for listening.